What you're seeing on screen right now is a 400-meter-long ship. That's the equivalent of 4 football fields placed side by side. Its weight? 200,000 tons. In other words, 500 times heavier than the largest aircraft on Earth. And the engine that moves this enormous structure is what I'm going to tell you about today. Because this engine is so powerful, it could supply an entire city with electricity. But how? Where does this power come from? And why does it have to be so massive? We're going to break it all down. Its name is Wärtsilä Sulzer RTA96C. That mouthful of a name belongs to the largest internal combustion engine ever built. Let's start with its dimensions. The engine stands 13 meters tall. That's 4 stories of a standard apartment building. It weighs 2,300 tons, which on its own is heavier than a small ship. It has 14 cylinders. Each cylinder is approximately 1 meter in diameter and 2.5 meters long. These cylinders move about 100 times per minute. Compare that to a typical car engine, running at 600 to 700 RPM. This engine much slower, but delivers unimaginably greater power. This engine produces 109,000 horsepower. For reference, a Formula 1 car produces around 1,000 horsepower. That means this engine is the equivalent of running 109 Formula 1 cars simultaneously. In energy terms, it generates 80 megawatts of electricity, enough to meet the entire power needs of a mid-sized district in Istanbul. You heard that right. This engine alone could light up a city. Car engines are typically 4-stroke: intake, compression, combustion, exhaust. But marine engines run on a 2-stroke cycle. What does that mean? Each piston stroke both generates power and expels exhaust. That means more power in fewer steps, a system engineered to eliminate inefficiencies and focus on raw output. The fuel. Not diesel, sludge. What these engines burn is called heavy fuel oil. It's the heaviest, dirtiest residue left over after refining petroleum into gasoline and diesel, and marine engines run on it. This fuel is solid at room temperature. Before it can be used, it must be heated to 150 degrees Celsius. It's a black, viscous, tar-like substance. Its price per liter is far below gasoline because nobody else wants to use it. Approximately 250 tons of this fuel are consumed per day. That's 90,000 tons per year, more than the annual sales of a small fuel station. There's a cost to all this power, of course. A single large container ship emits approximately as much sulfur dioxide per year as 50 million cars. That number may sound unbelievable at first, but consider this. That same ship is carrying 20,000 containers, each filled with thousands of products. When you calculate CO2 emissions per ton of cargo, maritime shipping is still far more efficient than air or road transport. IMO 2020 regulations, a forced transformation. In 2020, the International Maritime Organization, IMO, introduced a new rule. The maximum sulfur content in marine fuel would be 0.5%. The previous limit was 3.5%, a massive leap. To comply, companies faced 2 choices: switch to cleaner fuel or install exhaust cleaning systems called scrubbers. Either option means tens of millions of dollars in costs. LNG, ammonia, hydrogen, the fuels of the future. The industry is undergoing a major transformation. Ships powered by liquefied natural gas, LNG, are becoming more common. LNG reduces CO2 emissions by 25% compared to traditional heavy fuel oil. Even more ambitious projects are underway. Prototypes running on ammonia and hydrogen are being tested. These fuels theoretically offer 0 carbon emissions, but storage and safety challenges haven't been fully resolved yet. No matter how powerful the engine, it's the propeller that transfers that power to the water. Modern large ships have a single massive propeller, 9 to 10 meters in diameter, weighing 100 tons per minute. This propeller turns just 80 to 100 times per minute, but the mass of water it displaces with each rotation is so enormous that the ship can travel at 25 kilometers per hour. Yes, barely faster than a bicycle,
but carrying 200,000 tons. The engine can't just stop, an engineering problem. Did you know that these engines can't be stopped suddenly like a car? A ship running at full speed will continue moving for 3 to 5 kilometers even after the engine is shut down. That's why slowing down maneuvers must begin well in advance of a port. Reversing isn't instant either. Putting the engine into reverse requires a specific process that takes several minutes. Vibration, shaking a 400-meter structure. When 14 cylinders fire 100 times per minute, the vibration produced is extraordinary. To control it, counterweights and vibration dampers weighing several tons are installed throughout the ship's structure. Even so, you can feel the floor trembling if you're in the engine room. Engineers work in this environment for hours. Earplugs are mandatory, and prolonged exposure can cause serious hearing damage.
Picture this. You're 2,000 kilometers from the nearest coast. The engine stops. No tow truck is coming. No roadside assistance. Just you, your crew, and the sea. This is the nightmare scenario every chief engineer prepares for, and it happens more often than you'd think. Not catastrophic failures, but partial ones. A fuel injector seizes. A turbocharger loses pressure. A cooling pump fails at 3 a.m. The engine room never sleeps. That's exactly why the engine room runs on rotating 4-hour watch shifts, 24 hours a day. At any given moment, a qualified engineer is down there, not just monitoring screens, but physically walking the machinery, listening for changes in sound, feeling pipes for abnormal heat. These engineers can diagnose problems by ear alone. A slight change in the rhythm of the cylinders, a new vibration frequency. They notice it before any sensor does. The spare parts problem. Here's something wild. These ships carry spare parts that weigh several tons. A single replacement piston weighs around 300 kilograms. Spare cylinder liners, crankshaft bearings, turbocharger components, all stored on board, because if something breaks mid-ocean, you can't order next-day delivery. Major repairs at sea can take days. The crew works in extreme heat, with deafening noise, often in cramped spaces. It's not glamorous, but it's what keeps global trade moving.
So here's what we've learned. That pair of headphones, that shirt, that phone you ordered online, it most likely crossed the ocean on an engine like this, quietly, invisibly, in the middle of nowhere. The Wärtsilä Sulzer RTA 96-C has enough power to run an entire city on its own, but its real job is carrying the products of the world to the people in that city. Engineering sometimes hides its greatest stories in the most invisible places, and this engine may be the most perfect example of that. If you enjoyed this video, don't forget to subscribe. In our next video, we'll bring you another mind-blowing engineering story. See you then.